Hi there guys, this is The Average Joe, and today we're going to have again a bit of an engineering discussion, and we're going to talk. Um, Today's subject is actually why a good foundation is so important for your house. Um Now, this discussion came to be because today, the day before Easter, I had a talk with the shady contractor that my friend, that one of my best friends contracted to build his house, and this contractor had a problem with what I was saying, with dimensioning the foundation and so on and so forth. He was continuously saying, why do you insist on burying concrete and reinforcement in the ground? You're just burying concrete and reinforcement in the ground. But before we go further, please give a like to this video. Don't forget, subscribe to my channel, and we're going to start in a second. So guys, why do you need a good foundation on your house? First of all, let's put the problem this way. If you have a problem, you have your house with a ground, a foundation, and everything, yeah? If you have a problem with one of your walls, you can break the wall, put reinforcements, so on and so forth. If you have a problem with your roof, you change the roof. It's as simple as that. But when you have a problem with your foundation, you are in big trouble. One of the problems with the foundations is the fact that if you need to repair something on your foundation, it's usually very expensive. So everything above the ground can be repaired or replaced at a cost, but a relatively normal cost. It's not some crazy amount of money you have to put in that repair. At the foundation, whenever you have to make repairs on your foundation, you have to excavate the ground around your house, and usually till below your foundation you have to do all sorts of complicated works. That is one of the reasons why you need a good foundation from the start. It's very, very expensive to make repairs after the fact. Now, another thing is that when you have a good foundation, when your house has a good foundation, it means that everything is stable. Everything stays in place. The foundation is the only thing that connects your house to the ground. If your foundation is bad and the settlement in one end of the house is smaller than the settlement in the other end of the house, you're going to have cracks in your building. So a bad foundation brings all sorts of other problems. For example, if you have a bad roof, you'll have a leaky roof. Let's say you'll have a leaky roof. There's water going to enter into your house, into your attic. You just have to repair the roof, dry the attic, and you're over with it. You have a bad wall, it doesn't have enough insulation, or let's say, I don't know, you want to put another door or something like that. You break the wall, you put reinforcements around the wall, pour concrete, do all kinds of stuff, and you're done. Oh, one thing, you guys. Where I live, you're going to hear me many times saying pouring concrete in the walls, in the slab above the first floor, the ground floor, and that's only because in the area where I live, most of the buildings are built out of brick and mortar, and we don't really use a stick framing solution. Usually the houses where I live and in most of Europe are built out of concrete, with bricks, with mortar, with cement blocks, so on and so forth, masonry. We usually only have masonry. There it is a 90 something percent of houses are made out of masonry, and that's why I'm going to continue talking about masonry and concrete and so on and so forth. I understand in the States most of the houses are built on framing, on wood framing, and in your case in the States it's actually even easier to make repairs on a wall. You just put another wood beam, you put supports, and you're done. That's kind of the way it works, of course, in a very simplistic way. Now, going back to our foundation. Every time we build our foundation in a poor way, we're going to have settlements, we're going to have cracks, and there is one more thing. If we do not hydro-isolate our foundation properly, we're going to have water infiltration. But that's another problem. Now guys, if we want to talk about foundations, we have to also talk about the types of foundations you will find. There is the isolated foundation, being just a block of concrete, of reinforced concrete, under each pillar of the house. Okay? You then have a perimeter beam foundation. For the isolated foundation, if we were to look like this, we would see, let's consider a square house. This is the house. We will see a block of concrete here, one here, one here, one here. This is the simplest case, right? For a perimeter beam foundation, if we look from the top, you will see the house, the same square house, but you will see a foundation all the way around the house. This is a foundation on which the walls sit directly. You can also have pillars in the corners, no problem. Okay? There is another type of foundation which is used not that much on houses, at least not where I live, because of the frost line. There is also a slab on grade foundation, which means you have the house and you have your foundation, which can also have under the pillars or on the same perimeter of the building, can have an extended footing. This one, if you look at it from the top, you will see your house, you will see the exterior of the footing, and everything here is filled with concrete. Okay? Now, in my case, I'm just going to talk about a perimeter foundation, which of course inside of the house has a concrete slab, and inside of the foundation has a filling. Okay? These are the main types of foundations you're going to see out there. For this time, we're just going to talk about the perimeter foundation. So guys, in order to avoid problems with your foundation will need to be dimensioned properly by an engineer, or at least by somebody that knows what he's doing. But if you want to get all your permits, you need to have it done by an engineer. Now, you have the house with the roof. This is the ground. This is the foundation. How does an engineer actually know what is the proper dimension for your foundation? Well, your house has a weight of its own. And everything you put in the house, including the humans, okay? You then have a wind loading. If you're unfortunate enough to live in an area where there's snow, you're also going to have snow loading. And if you're even more unfortunate and live in a seismic area, you're going to have a seismic force. Now, before you all jump on conclusions, for the seism, for the earthquake, it used to be calculated like this, with just a seismic force. I'm not doing that usually. This is just simpler for me to show. But we're going to get to that in a moment. Now, the weight of the house. Considering the materials you want to use and considering a number of standard factors, depending on the size of the house and the distance between the pillars of the house and the way that the entire weight is distributed, you're going to get a loading in the footing. That's the first loading, it's the dead weight. Now, in the same time, if you have winter, you're going to have a snow loading. That's going to act just like a dead weight on the house, and you have to transfer that to your footings, to your foundation. In some areas you have to take into consideration a wind loading. That wind loading is usually only considered from a specific part of the house, a dominant wind direction. You can also make a suction calculation, considering that you have the wind from one side and through the aerodynamics of the building you're going to have suction on the other side. At houses you don't really do that. You're usually not doing that. I, for one, design bridges on my day-to-day job, and we are actually considering the suction on one, wind on one side, suction on the other, depending on certain situations. And there comes the seismic force. Well, if you look in the Eurocode, you can see that you can still use a seismic force, but on the other hand, you can go the more complicated route and the more exact route, and make a time history analysis, and for that time history analysis you are using a known accelerogram of a known earthquake, and you put that in a finite element program, you model everything, and that's how you end up with a result. After you've done all of that, you compute all the loadings into the same model, into the same calculus sheet, and you will actually find the dimension of the footing. How wide it has to be, and you play with your depth of the foundation, and with the width of the foundation. You actually can sometimes go a little bit deeper, just a bit deeper, and make your foundation slimmer and be more cost effective than going with a shallower foundation and wider foundation. Of course, the width of the foundation is sometimes limited by the width of the walls, meaning you cannot go with the foundation with a width smaller than the width of the walls, because your walls, being masonry in this case, in our cases, the foundation has to support the width of the bricks and a little bit more. So sometimes you just simply cannot go on a very skinny foundation. Now, I've said that the subject for today is why it is important. Well, first of all, it's important to have a good foundation because you don't want your house crumbling, and you don't want to have to make expensive repairs. Second of all, having a good foundation, a well thought out foundation designed ahead of time, can save you a little bit of money. Not an extraordinary sum of money, but you can save money because you use the least amount of concrete needed and the least amount of rebar needed. Even if it might seem a lot, if you do not build your foundation properly, in most of the cases, you're not going to make savings. You're just going to have problems down the road if it's not dimensioned properly. Now, the same idea applies on all types of foundation. It doesn't matter if they are isolated foundation, if they are foundations, if they are perimeter beam foundations, or if it's a slab on grade. A foundation has to be calculated properly in order to support the loadings properly, and it has to be below the frost line if you have a frost line in your area. I know there are many places where you don't have frost and you don't have to go below a certain level to exceed the frost line, and there are also places that do not consider a frost line because most of the time the earth is frozen up and you consider your foundation sitting in frozen ground all the time. I know. In my case, where I am in Europe, I have to consider a frost line, so I consider a frost line. So guys, I hope you learned something new today. I hope you understood something new, you found out something new. I hope you will get a better understanding of why you need to do things the way on your house, at least some things, why you need to do them as the engineer says you need to do them, and you don't just do it as your gut say. If you're not an experienced builder, I hope you don't fall in the same trap as my friend, and you don't go on building something when your contractor says it will be just fine, it will work, it will also work this way, don't worry about it. If your engineer says no, it won't work, you should probably start putting some questions and, be a little bit skeptic. So I hope this video will help you. Please give a like to this video, don't forget, subscribe to my channel, and see you next time.